In this video, we're going to learn how to solve quadratic equations by using a new strategy called completing the square. So in order to use completing the square to solve a quadratic equation, we need to actually understand what a perfect square trinomial is. So on the screen, I have three perfect square trinomials. And what we're going to do is we're going to inspect them a little bit. We're going to look at what they look like when they are in factored form, and then we're going to look for some patterns that we can apply so we understand how perfect square trinomials are created. So the first thing you need to notice in each of these is that our a value is equal to 1. So we'll be able to use our factoring shortcut here because a is equal to 1. So we need two numbers in example 1 here that multiply to be 1 times 25, which is 25, and add to 10. Now hopefully you know that two numbers that multiply to be 25 and add to 10 are 5 and 5. So we can write this into factored form, which is x plus 5 times x plus 5. And then because we have something times itself, this can be rewritten as x plus 5 squared. So we were able to take this perfect square trinomial and rewrite it here as x plus 5 quantity squared. Then if I look at this second example here, I need two numbers that multiply to be 1 times 49, which is 49, and that add to be negative 14. Well, hopefully you're already thinking of negative 7 and negative 7, so this can be rewritten as x minus 7 times x minus 7, and since it's the same thing times itself, it can be written as x minus 7 quantity squared. Then from here, this third one down here, we have an a value of 1, as we discussed earlier, so we can again use our factoring trinomial shortcut. So we need two numbers that multiply to be 1 times 9, which is 9, and add to be that negative 6. So if I think about that, I have negative 3 and negative 3, so this becomes x minus 3 times x minus 3. And we end up with x minus 3 quantity squared. So every time we have a perfect square trinomial, it can be written as x plus or minus a number squared. So we can see that in all three of these. Now, what I also want you to notice here is a pattern amongst all of these. And this pattern relates that piece that is squared to that original perfect square trinomial. Now in all of these, we know that the a value is equal to 1. Now if you look closely at your b value in these perfect square trinomials is whatever this number is. Here it's 5, here it's negative 7, and here it's negative 3 times 2. So you can see that it's that number times 2. And then our c value is that number, so we have 5, negative 7, and negative 3. It's that number squared. 5 squared is 25, negative 7 squared is 49, and negative 3 squared is 9. So we're going to use this pattern here of a is always 1, b is that number times 2, and c is that number squared in order to write items into a perfect square trinomial. So our goal on this slide here is to figure out what we need to add to each of these expressions in order to make it a perfect square trinomial. So we're trying to figure out, okay, we have x squared plus 16x plus a number, and we want that to turn into something times itself, which eventually will become x plus or minus a number squared. So ultimately, we need to figure out what this number here is so that we can then work backwards and figure out what we need to add here in order to create a perfect square trinomial. So, if we remember the patterns from the previous page, we know that a was always equal to 1. We then also know that b is going to be equal to whatever our number is inside of here, whatever that number is, times 2. So that's going to relate to the 16x here. And then our c value, which is what we're missing and trying to find, is going to be equal to whatever our number is squared. So we need to figure out what this number is here in order to then work backwards and figure out what our missing c value is going to be. Now remember, our b value, which we can see is right here, is our number inside of here times 2. So if we think about it, we need to figure out what number times 2 gives us a positive 16. Well, when I think about it, a positive 8 times 2 gives me negative 16. So our perfect square trinomial here is going to be x plus 8 in parentheses squared. So we want to figure out what number we need to add here in order to get x plus 8 quantity squared. Now if we think about the pattern we saw on the previous page, we know that the c value, which is the value that's missing here, is always going to be the number that I have inside of the parentheses squared. So if I take 8 squared, I end up with 64. So 64 is the missing number that I need in order to turn this into a perfect square trinomial. So I can see if I add in the 64 there, x squared plus 16x plus 64 can then be rewritten as x plus 8 times x plus 8, which turns into x plus 8 quantity squared. So now if I move on to example 2 here, I again want to figure out what I'm going to add in here in order to make that a perfect square trinomial. So my goal is to end with something that will produce x plus or minus some number in parentheses squared. So if I think about this, I know that this number, it creates this b value here. And whatever our number is times 2 creates this b value. So I have to think about what number times 2 gives me a negative 18. Well, I know that negative 9 times 2 gives me a negative 18. So what's going inside of this parentheses here is a minus 9. Then from here I can continue to work backwards and find my c value that's missing. I know my c value up here is created by taking my number, which in this case is negative 9, and I take negative 9 and I square it. So the missing number here that I need to add in order to make this a perfect square trinomial is 81. And finally, let's look here at example 3. Again, our goal is to figure out what we need to add in order to make that a perfect square trinomial. So our goal is to figure out what goes inside of this parentheses. It's going to be x plus or minus some number, quantity squared, and that's going to work backwards and produce this perfect square trinomial. Now remember, in order to create this b value here, we took our number and we multiplied it by 2. So we have to figure out what number times 2 gives us 5. Now if you're thinking that's not a nice number, you are correct, because the number times 2 that gives us 5 is 5 divided by 2, which is 2.5. So what's happening in this particular problem is the number inside of this parentheses here is a plus 2.5. So I understand that's not a nice number, but even with numbers that are decimals, we can use completing the square. So from here we know that our number inside of the parentheses is 2.5. Now we also know that we can utilize this number inside the parenthesis to find our c value, because it's just that number squared. So if we take 2.5 and we square it, we find that that's equal to 6.25, so the number we need to add in here to make this a perfect square trinomial is 6.25. So now we're going to take everything that we learned about perfect square trinomials and we're going to use that to help us solve quadratic equations by completing the square. So when you use the completing the square strategy, what you're going to do is you're going to put everything that contains an x squared and an x on one side, and you're going to put all of the constants on the other side of the equation. Because what we're going to do is we're going to really focus in on this piece right here, and we're going to try to figure out what we need to add to x squared plus 20x, what we need to add to that in order to turn that into some sort of perfect square trinomial. So our goal is to end up with x plus or minus some number quantity squared on the left-hand side. So if I think about this, I need to figure out what I'm going to add there. And again, I'm going to think back to my properties. I know a is 1, b in a perfect square trinomial is a number times 2, and c is that number squared. So I look at my b value here and I notice that it's 20. So I know that inside of these parentheses is going to go a plus 10 because it's 20 divided by 2, because 2 times 10 gives us 20. Now we take that number, which is 10, and we need to square it to find our missing c value. So we take 10 squared and we find out that that is 100. So what we're going to do is we're going to add 100 to the left-hand side of this equation in order to turn it into a perfect square trinomial that can be written as x plus 10 quantity squared. Now when we do that, we can't just add 100 to the left-hand side and not do the same to the right-hand side. You know the rules of solving equations. Whatever you do to the left-hand side of the equation, you also must do to the right-hand side of this equation. So we're going to add 100 as well to the right-hand side of this equation. So by creating a perfect square trinomial, I now have x plus 10 quantity squared on the left-hand side, and I have 116 on the right-hand side. So now I currently have this equation of x plus 10 quantity squared is equal to 116. So by using completing the square, I was able to rewrite this by using my knowledge of perfect square trinomials. Now hopefully what you're thinking is that this looks a lot like the problems that we solved when we used the square root strategy. And it is. When we're using completing the square, we're basically setting this up so that we can use square roots to finish solving this quadratic equation. So here, in order to get the x value by itself, we're going to square root both sides. Remember when we square root a squared, this becomes plus or minus the square root of 116, and this equals x plus 10 now on the left-hand side. Now I always want to make sure that my square root is perfectly simplified. So if I go through the perfect squares, I notice that 16 is divisible by 4. So this turns into the square root of 4 times the square root of 29. So that's plus or minus 2 square roots of 29. And then in order to finish getting x alone, I need to subtract 10 from each side. So my final answer here is x equals plus or minus 2 square roots of 29 minus 10. So let's practice a second example. So again, we're using completing the square. And when we use completing the square, we want everything with x's on one side of the equation and all of the constants on the other. So I'm going to start here by subtracting 50 from each side. So remember, the starting point is different for these completing the square problems. So here I have x squared minus 6x is equal to a negative 50. And now that I have this set up, my goal is to turn this left-hand side of the equation into some sort of perfect square trinomial. So I have x squared minus 6x. I'm going to add in some value is equal to negative 50, and then I'll add that same value onto the right-hand side eventually. So I know that my perfect square trinomial is eventually going to be written as x plus or minus some number squared. So I need to figure out what I'm adding in here, and I need to figure out what this number is inside of the parentheses so I know what is being squared inside of that with x. So I need to start by thinking about the patterns I know about perfect square trinomials. I know my a value is equal to 1, my b value is equal to whatever my number is times 2, my c value is equal to my number squared. So if I think this through, I know that my b value is equal to negative 6, and as a result, my number inside of the parentheses needs to be half of that because my number times 2 gives me negative 6. So this must be negative 3. And then from here, because I found the number inside of the parentheses, negative 3 squared is going to help me find c. So I'm going to add 9 here because negative 3 squared is 9. So if I add 9 onto the left-hand side of the equation, I can create a perfect square trinomial over there. However, if I add 9 to the left-hand side of the equation, I also need to add 9 to the right-hand side of the equation. So what I really have here is x minus 3 quantity squared is equal to negative 41. So I now at least have something that I can solve. So I've completed the square, and now I can utilize the square root strategy to finish solving this. So I start by square rooting both sides. So my left-hand side becomes x minus 3 is equal to, then when I square root that squared, the right-hand side becomes plus or minus the square root of negative 41. Now I know that I need to attempt to simplify this, and I notice that 41 isn't divisible by any perfect squares, but because there's a negative underneath that square root, I know I need to simplify this further. so that we don't have a negative under the root. So I can rewrite this as the square root of negative 1 times the square root of 41. And as a result, this becomes plus or minus I times the square root of 41. So then from here, my last step that I need to do in order to get x alone is I need to add 3 to each side. So I end up with x is equal to plus or minus I times the square root of 41 plus 3. And then remember, the most standard way to write this is to put the real part first. So we would write x equals 3 plus or minus I times the square root of 41. Okay, third and final example here. So in this one, we are going to again get the x's all on one side and all of the constant numbers on the other side, since we're using that completing the square strategy. And our goal is to turn this part into some sort of perfect square trinomial. So I start by subtracting 40 from each side. So I end up with x squared plus 9x is equal to a negative 36. So then from here, what I'm going to do is I'm going to try to figure out what I need to add in here in order to turn this into a perfect square trinomial. Now I know that it's going to end up as x plus some number in parentheses squared, and my goal is to figure out what this number actually is. Now again, if I think through my patterns of perfect square trinomials, I know a is equal to 1, b is equal to whatever my number is times 2, and then c is equal to whatever my number is squared. So I'm trying to figure out what my number inside of that parentheses is. Well, I know that my b value is 9, so if I take 9 and divide it by 2, I end up with 4.5. So my number inside of the parentheses here with x is a plus 4.5. Now, in order to find the c value that I need to make that possible, I need to take 4.5 squared. Now, if I do that on my calculator, I find that 4.5 squared is about 20.25. So I'm going to add in 20.25 here. And remember, if I add 20.25 to the left, I also have to add 20.25 to the right-hand side. So now I know that I have x plus 4.5 squared is equal to negative 15.75. So now we need to solve and get x alone, so we square root both sides. We end up with x plus 4.5 is equal to, because we square root a squared, this becomes plus or minus the square root of negative 15.75. And then because I have a negative underneath the root, I'm going to deal with that right away because I know that relates to the imaginary I. So this becomes plus or minus I times the square root of 15.75. So normally we wouldn't evaluate the square root unless it was a perfect square. We would leave it as a simplified square root. In this case, because we already have a decimal underneath that square root, we can't really simplify it further. So I'm just going to estimate and evaluate this. So typically, again, you simplify your square roots, but if you have decimals involved in the problem, you can go ahead and estimate that to the nearest hundredth. So if we take 15.75 and we square root that, we end up with about 3.97. So that's an estimate there. So this would become plus or minus 3.97i. And then from here, our last step is to subtract 4.5, subtract 4.5. So we can write x is equal to plus or minus 3.97i minus 4.5, or if you write this in standard form, your real part comes first, so that's negative 4.5 plus or minus 3.97i.